Alright, so hello everyone. Today's your last class. I'm going to go over what we learned, and then at the end we're gonna play a fun game. So hopefully you're excited for that. So, a precursor. Over the last few weeks, we've learned pretty much all there is to say about geometry. Just kidding, but hopefully you learn more about geometry than you know more about geometry than you did when you started. So after these review slides, we're gonna have a competition slash quiz. So hopefully to see if you guys have learned anything, and hopefully to have some fun. So remember on day one we talked about angles. So there's three ways to classify angles. You can classify them as acute if they're less than 90 degrees, right as if they're equal to 90, and obtuse if they're greater than 90. And furthermore, two angles are called complementary if they add up to 90 degrees, and they're called supplementary if they add up to 180. And so for instance, 89 and 1 are complementary angles because they add to 90. Alright, next we're moving on to slopes. So a slope in math, it indicates how steep a line is. So you can see that the red line has a slope of 2, so it's a lot steeper than the blue line, which only has a slope of 0.1. And to calculate it, you choose 2 points on the line, and you calculate the rise over the run, which is how the change in y divided by the change in x. Alright, transversals. These two parallel lines, they're cut by another line that's called the transversal, and they form a lot of supplementary and identical angles. So opposite angles, because opposite angles are equal, adjacent angles are supplementary, and you can see in this picture all the names with equal sign beside them, it means they're equal, and equal 180 means they're supplementary. So now here's the distance formula. So if you want to find the distance between 2 points in the Cartesian plane, you just plug it into this formula. And if you even though it seems pretty simple, it's also used in the formula for a circle, and also to find the equations of tangent lines. Alright, so now on the second day, we covered triangles. So to make sure that a triangle is a triangle, you have to know that the sum of any two sides must be greater than the third side. And the sum of the angles in the triangle is always 180 degrees. And the area, it's going to be 1/2 base times height. But if they only give you the 3 side lengths and you don't want to find the height, you can also use Heron's formula, which is on the right. So it's the square root of, well, you can hopefully see for yourselves, because I kind of don't want to read that out loud because it's really long. And S is called the semi-perimeter because it's exactly half of the perimeter of the triangle. And also types of triangles. So a triangle is acute if all angles are acute. It's right if it has a right angle, and obtuse if it has an obtuse angle. And you can also classify triangles by their side instead. It's an equilateral triangle if all sides are equal. It's isosceles if 2 sides are equal, and it's scalene if no sides are equal. And with right triangles, there's something special called the Pythagorean Theorem, which relates the side lengths of 3 sides. If you know the legs A and B, you can find the hypotenuse C, given that A squared plus B squared equals C squared. And we also went over the proof for that, so hopefully you guys remember. And so here's some common Pythagorean triples, which means that they form the 3 sides of a right triangle. It's 3, 4, 5, and its multiples you should know, because we had taught similarity, and similar triangles, you just scale it up or down, and that still means it's a right triangle. And also 5, 12, and 13. So that's another Pythagorean triple that you might have seen. Alright, day 3. On the third day, we covered quadrilaterals. So first of all, the angles in the quadrilateral sum to 360 degrees. And so we split quadrilaterals into certain types. You can see a trapezoid, it has one pair of parallel sides. A parallelogram, it has two pairs of parallel sides. And a kite, instead of being parallel, it only has the requirement deals with side lengths instead. It says that two pairs of the adjacent sides have to have equal length. And finally, a rhombus, all sides have the same length. A rectangle, it's a parallelogram with four right angles. And a square, it basically has all the properties, except if you consider that a trapezoid, it only has one pair of parallel sides. When a square, it has two pairs of parallel sides. All right, so the area, in both parallelograms and rectangles, the area, its area is the base times height. In the trapezoid, it's base, well, 1/2 base 1 plus base 2 times height. And you can think of this as the average of two bases multiplied by the height. And B1, B2, that just means the length of the two parallel sides. And we call those the bases. And finally, a kite, it's equal to 1/2 times the product of the diagonals. Because that's usually an easier way of finding the area than calculating it by the side length. And finally, for rhombus, it's also going to be 1/2 the product of the diagonals over 2 because a rhombus is a kite. And finally, a square, you use the formula for a rectangle, which is base times height, but since they're equal, it's just the side length squared for a square. All right, so on to day 4. On the 4th class, we learned about circles. And a circle, it was defined as all the points in the plane that are a certain distance r away from another point that's called the center. And that's the definition. And the diameter of a circle, it's 2 times the radius. And finally, pi, the special number, it's a ratio between the diameter and its circumference. So it's actually equal to the circumference of any circle divided by the diameter. And as you can see, circumference equals 2 pi r because 2r is the diameter. And the area of a circle is pi times r squared. So congruence and similarity. Congruence and similarity are similar yet different. Funny joke, I guess. Haha. So congruence, it just means that one shape is a rotated or moved version of another version of the same shape. So they're the exact same. All their side lengths and all their angles are the same. And you can basically overlap them and it would look like the only one shape. While similarity, it could be rotated or moved, but it's also scaled, like it could be bigger or smaller. So if the side length is scaled by x, then the area is scaled by x squared. And if you move this up to 3D shapes, then the volume, if the side length is scaled by x, then the surface area is going to be scaled by x squared, and the volume is going to be scaled by x cubed. And so in triangles, if you know that two angles are the same between the two triangles, you know they're similar. You can also, if you also know that a side angle and the side, if you know the angles are the same and the sides form a common ratio, then they're similar. And also, if you know all three sides and they form a common ratio, then you know that they're similar. All right. Now we're going to move on to types of prisms. So a prism, it's formed by extending a base in third dimension. And so the volume of a prism is equal to the area of the base times the height of the prism. And the surface area of the prism is equal to 2 times the area of the base plus the lateral surface area, which is all the rectangles that's formed on the sides. And finally, it should be the volume of a cylinder, but I don't know why I wrote code. So the volume of the cylinder, it's because cylinders are prisms. It's just a prism with a circle as the base. You just use the same formula again. Given the radius, the area of a circle with the radius r is pi r squared, and that's the area of the base. So you multiply by height to find the volume of a cylinder. Yeah, so it should read cylinder, not cone. And same thing, the surface area of a cylinder, it's a bit more complicated, but anyway, it's 2 pi r squared for the two bases plus 2 pi r times h, which I taught is what you get if you unroll the cylinder and it forms a rectangle instead. Alright, so we're going to move on to pyramids. So pyramids have one base, and every point on the perimeter of that base is connected to a point on top that's called the apex. So the volume of any pyramid is 1/3 times the volume of, times the area of the base times the height, and that's because 3 pyramids can be fit into the space of a prism that has the same base and height. And so the surface area of a prism is going to be the area of the base plus the lateral surface area, which is all the faces except for the base. And you can use the slant height to find the area of the lateral triangles that form the area of the lateral surface area. And finally, for cones, same thing. You just plug in instead of using the area of the base in general for a cone. If you know the radius, then you can calculate the area of the circle. That's the base, and you just plug that in as b. And the surface area of a cone, it's a bit more complicated to derive, so I just wrote it down here. It's the volume, the area of the base, which is the circle, plus the area plus the area of everything else, which is going to be pi times r times l, and in this case, it's the slant height, which you can find using the Pythagorean theorem on the height and the radius. So it's going to be the square root of r squared plus h squared. All right, so spheres. The volume of a sphere is 4/3 pi r squared, and the surface area is 4 pi r. For the volume of a sphere, it should be 4/3 pi r cubed, and the surface area is going to be 4 pi r squared. All right, so thanks. Do you have any questions? Feel free to email us, and we're just kidding. As something fun to do, we're gonna have a small competition. And so I'll send the link in the chat for you guys to join. So good luck on it, and hopefully you guys have fun. And in the end, I'll show you guys the rankings. Okay, so I guess I'll let you guys have a okay, so in the chat, if you want to break right now, type in the chat that you want to break. Otherwise, we're gonna start as soon as everyone joins. So basically, we're gonna have a vote to see if we should have a break or start the game right now. So I guess since some of you want a break, I'll give you guys a 5-minute break, and we'll start at well, it might not be 8 where you are, but 23. So when the minute says 23.
Instructor game now.
Alright then, so it's 8:23 or whatever, based on whatever time zone you're in, so I'm going to start the game and good luck and have fun.
Wait a second. How are people moving up from the leaderboard? Oh,
Alright guys, so I hope you guys enjoyed it. So for the final leaderboards, I think I'll remove all the alts. So sorry, Joe Bob. But you had a lot of alts, so yeah, sorry. I just want to be fair. So I think these are pretty fair for the rankings. So
There was a Joe Mama and a Joe Bob too. Joe Bob, 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 Bob.
oh, but I think Joe Bob was in the game from the start. I don't think he's an alt. I don't think so. Alright, so I'm just gonna break it to you guys. So I was the person in first place. Wow, such a surprise, but I'll remove myself. Alright, so the final rankings. I really don't know who H is.
That's me.
Oh, good job then. On getting first. Then there is Cool, Joe Bob, Bob. Enter your name and Joseph for the top 5. And you can see all the rankings here. So now I'm going to go over the answers to the questions. So the first question, actually I'll sort them by accuracy. All right, so you know what? Actually, I'll just go by order. So in the first question, in what type of triangle are two angles guaranteed to be complementary? The actual correct answer is right triangle. Well, because you know that all the angles in the triangle add up to 180 degrees, and because one of the angles in the right triangle is 90 degrees, so if you subtract 90 from both sides, you get that the other two angles in the right triangle always add up to 90 degrees. So, number 2, I see that most of you guys got this right. What does the slope of a line determine? Well, it determines how steep a line is. How long a line is, it doesn't matter because all lines are infinitely long. Where the line intersects the y-axis, that does not, that's called the y-intercept, which is not the slope, and where it intersects the x-axis is called the x-intercept. And 3, I see that most of you guys also got this one right. If a line has a slope of 10, what's the slope of a line that's parallel to it? Well, parallel lines, they have the same slope, so it's also going to be 10. Number 4, I see that half of you guys got this one wrong. So what you do is you move the x to the other side to get the slope. So you subtract both sides by 5x, and you divide both sides by 2 to get that y equals negative 5 over 2x. And it doesn't matter what the final thing is because negative 5 over 2 is going to be the slope. So you know that negative 5 over 2 times the slope of the perpendicular line is going to be equal to negative 1. So the answer is going to be 2/5. Alright, this is from the equation of a circle. But what you can do is if you square root both sides, you get the distance equation to find that the distance from any point to the point 1, -3 is going to be 9. And so that's, by the definition of a circle, it's going to be 9. The area of a triangle with side lengths 28, 35, and 21. Okay, so you can see that it's actually a multiple of the 3, 4, 5 triangle, and it's you can see it's scaled by 7. So what you do is you scale the area of a 3, 4, 5 triangle, which is 6 by 49, to get the answer is 294. And finally, find the area of a quadrilateral equilateral triangle with side length 2. If you break it up into two 30, 60, 90 triangles, you'll get that the final answer is root 3. And if you know that one base has length 2, and that, well, I see most of you guys got this right, and that the trapezoid has area 7 and height 4, what you can do is you just divide the area by the height to find the average of the two base lengths, and you'll find that the answer is 3 over 2. Alright, this question, I see that some of you guys struggle with it. So the length of a diagonal of a square with sine length x, we'll use Pythagorean theorem to get that the square root of 2x squared is going to be equal to that length. So the length of the diagonal is root 2x. if the radius of the sphere is doubled, what happens to its surface area? Well, the surface area is related to the radius squared, so it's gonna quadruple, which is multiplied times 4. And all squares are rectangles, but all squares are also quadrilaterals, parallelograms, and rhombi. And then we're almost done here. If you know that two triangles both include angles of 37 and 13 degrees, well, by angle-angle similarity, you know that they're going to be similar. And finally, last few questions. If the radius of a cylinder is tripled, but the height is halved, what happens to the volume? Well, the volume is related to r squared times h. And so if you triple that, you're going to get 9/2. So it's going to be 9/2 times the previous volume. And again, if the radius of a cone is tripled but its height is halved, what happens? Well, it's going to be the same case as the cylinder because it's still related to r squared times h. So it's going to be 9/2 times. Wow, okay, last few questions. If a sphere of radius 3 is filled with water, it's going to be poured into a prism with a base area of 6. Well, you just find the volume of the sphere, and then you divide by the base area to find the height, and it's going to be 6 pi. Finally, maximum area of a rectangle, given that its two side lengths add to 6. Well, you guys will hopefully learn about the arithmetic geometric mean, like inequality later in life. But you find that it's going to be the product is going to be maximized when they're equal. So it's going to be 3 and 3, which multiply to 9. And finally, what's the length of a chord? Well, if you draw the picture, and then yeah, so if you draw the picture, oh wow, okay. So I actually messed up on this question. So the final answer is actually none of the above. But well, the correct answer, but that's obviously not an option. So what you get is that half the length of the chord is 5. If you draw it and you form a right triangle, but actually the whole length of the chord should actually be 10. And then finally, if you ignore units, how many times larger is the volume of the sphere than the surface area, given that the sphere has a radius 2? So what you do is you calculate the volume as 4/3 times 2 cubed, which is 32/3, and then you divide that by 4 times r squared, which is going to be 16, to get that it's 2/3 times. So it's actually 2/3 the surface area. And yeah, so that's all the questions. Well, this is gonna be the end of the class, and since it's the last class, I'll let you guys go early. So hopefully you enjoyed it and learned something. So goodbye, everyone.
Bye. Thank you. Have a nice day.